What I want to do right now is use the following computations to help me develop formulas for compound interest. So let's say that you have $100 in an account that pays 5% annually. How much is going to be in that account after 1 year? Well, you have the $100 that you started with plus 5%, which we find by taking 0.05 times that 100, which is $105. I'm not interested so much in the actual amount as much as seeing a pattern, so I can come up with a formula. Okay, notice 100 is a common factor to each of these two terms, right? So I'm going to factor out the 100. When I factor it away from the first term, I'm left with 1 plus. If I factor it away from the second term, I'm left with 0.05. Okay, so that's how much money I have after 1 year. Well, for the second year, what we're going to have is that $105, which I'm going to go ahead and write as write it in the form 100 times 1 plus 0.05, and then at the end of the year the institution would pay you 5% of that, so I'm going to go ahead and take 5% of 100 times 1 plus 0.05. Well, if you look at this, 100 times 1 plus 0.05 is a common factor of each term. So let's clean this up a little bit. I'm going to go ahead and factor out the 100 times 1 plus 0.05. And when you do that, in this first term, you're left with a 1 plus, on the second term, a 0.05. Okay, oh, look, we have a repeated factor there, right? So I can rewrite that as 100 times 1 plus 0.05 squared. Right? So it seems to be a little bit of a pattern here, right? When it was only 1 year, we multiplied the 100 times 1 plus 0.05. When it was 2 years, we multiplied the $100, our initial investment, times 1 plus 0.05 squared. Okay, so from this pattern, what might one conjecture about the amount of money in account after 3 years? Well, the pattern seemed to be, we take the 100 times 1 plus 0.05 raised to the number of years, right? So for 3 years, we'd have 3 as our exponent. So then, if you have the money in the account for T years, you can have that initial investment of $100 times 1 plus the interest rate, which was 5% in decimal form, and then raised to the number of years, right? So raised to the T. And that's exactly where we get this formula for the amount of money in an account when you start off with an initial investment of P dollars, and the interest rate is R in decimal form, and you leave it in there for T years, then the amount of money after those T years in the account will be A of T equals the P times 1 plus R raised to the T power. Okay? So then you can imagine if the money's compounded more than 1 time per year, essentially you're just going to go through the same process I did above, n times each year, which means you would be multiplying the 1 plus R by itself n times for just 1 year, right? And then you would do it again for 3 years, etc. Well, the other thing that you need to note, though, is when a bank says that they're going to compound n times per year, they're not going to give you that full interest rate n times during the year. What they'll give you is the interest rate of R divided by n raised to the nt. Okay? So, for example, if it's compounded semi-annually, n would equal 2. That's for semi-annually. If it's compounded quarterly, what would n be? So quarterly would indicate it's done 4 times a year, so n would equal 4. Okay. Monthly, n would equal to 12 because it's compounded 12 times per year. And daily, and they would use n equals 365. Okay. Now, if they say it's compounded continuously, in that instance, essentially that means we're well, it doesn't mean that there's somebody actually sitting down in the vault continuously compounding using a formula like this. What they're saying is they are going to use this formula here, okay? But this is just a formula P times E raised to the exponent R times T, where P is the initial investment still, R still the interest rate in decimal form, and T still the number of years. So in these compound interest problems, what you want to do is first off determine which formula to use, how many times it's going to be compounded, and then you want to identify which information you're given and identify what you need to find. So let me just work one example. You invest $500 at 7% interest compounded annually. Okay, so if it's compounded annually, that means I'm going to use that first formula, right? Because it's just compounded 1 time per year. So in that case there, the principal is the initial investment, which is 500. The interest rate is 7%, so it's 0.07. And the number of times per year is once. So that just means, oh, and we're given that t equals 2. So we're actually looking for a of 2, where we're plugging it into this first formula here. So it would just be the initial investment of 500 times 1 plus 0.07 raised to the second power, right? And one could punch that into the calculator and round it off to the nearest penny. This is also here compound annually. Notice the difference. If you're asked, oops, I know it keeps going back up there. Let me try one more time. This third problem, here you could select different times that it's compounded. So on this one, when it's compounded annually, n is 1. Compounded quarterly, we would have n equals 4. And compounded continuously, we would then use the formula A equals P times E to the RT. Here we're going to use A equals P times the quantity 1 plus R over 4 raised to the 4 times T. And this one, we would use that formula that I developed. So A equals P times 1 plus R raised to the T power. So this was just meant to give you an initial introduction into where the formula comes from. And now you should be in shape to go and substitute in values that are given and find the value that is unknown.